There's two laws that we have to talk about besides the power law. The product law tells us that the log base b of x plus the log base b of y is equal to the log base b of x, y. Of course, b has to be greater than 0, b cannot be 1, and x and y have to be greater than 0. Because remember, the argument of a log must be 0. Sorry, it must be greater than 0. It has to be positive. So you got the product law, and you've got the quotient law, which says the log base b of x minus the log base b of y is equal to the log base b of x over y, subject to the same conditions as before. B has to be greater than 0, b cannot be 1, x has to be greater than 0, y has to be greater than 0. And to see how these apply, we're going to work through page 384. Basically 1 to 10, just not 8. Number 1. They want us to simplify using the laws of logs. This is just going to be the log of 9 times 6. So the log of 54. Now, to save some time, you'll notice that in question 2 it says use a calculator to evaluate correct to 3 decimal places. So I'm just going to do that at the same time. The log of 54 correct to 3 decimal places is 1.732. It should be a familiar number. Log 48 minus log 6. And you notice they don't specify the base there, meaning that it's a common log. 48 and 6 are both positive and none of them is 0. The base is 10. 48 divided by 6 is 8. So that's going to be log of 8. Correct to 3 decimal places, that's going to be 0.903. Log base 3 of 7 plus log base 3 of 3, that's going to be log base 3 of 7 times 3, or log base 3 of 21. Now, to evaluate this, we're going to have to use the change of base formula on our calculator, and we're going to evaluate that on our calculator by doing log base 21 divided by common log of 21 divided by common log of 3. And correct to 3 decimal places, that's going to be 2.771. So log base 5 of 36 minus log base 5 of 18 is going to be log base 5 of 36 divided by 18, which is the same as log base 5 of 2. And to evaluate that, again, you can use your change of base formula. Log base 5 of 2 is the same as log base 10 of 2 divided by log base 10 of 5. On your trusty calculator, log base 10 of 2 divided by log base 10 of 5 is going to give us 0.431. So 4a says log base 6 of 18 plus log base 6 of 2. That's the same as log base 6 of 18 times 2. That's going to give us log base 6. 18 times 2 is 36. 36 can be written as 6 squared. And using our power law, we can say that's 2 times log base 6 of 6. Now this part is 1. So that's equal to 2. So the next one is log 40 plus log 2.5. That's the same as log of 40 times 2.5, which is the same as log of 100. But 100 is nothing but 10 squared. 2 comes down, you've got log, common log of 10 is just 1. So this is going to be log base 12 of 8 times 2 times 9, which is the same as log base 12. 8 times 2 is 16. 16 times 9 is 144. But 144 is nothing but 12 squared in disguise. 2 comes down, log base 12 of 12. Now this bad boy is just 1, and I know you're shocked. The answer is 2. So this is going to be the same as log 5 times 40 times 5. 5 times 40 is 200. 200 times 5 is 1,000. So that's the same as the log of 1,000, which is the same as the log of 10 cubed. which becomes 3 times the common log of 10. This is 1. And so our answer is 3. I'm kind of confused as to why it's not 2, but at least it answers the question as to how many 2's we got. We got 3. So this is going to be log base 3 of 54 divided by 2. Log base 3, 54 divided by 2 is 27. That's the same as 3 cubed. That comes down in front. The log base 3 of 3 is 1. Log 50,000 minus log 5. That's the same as log 50,000 divided by 5. Log 10,000. Log of 10 to the 4. 4 comes down. Common log of 10 is 1. It's not 2 or 3, it's 4. So that's going to be the same as log base 4 of 320 divided by 5. 320 divided by 5. 5 goes into 36 times and goes into 24 times. That's the same as log base 4 of 4 cubed. This is 1. This is going to be log 16 of 2 cubed plus log 16 of 8 squared minus log 16 of 2. These two are going to get multiplied and then divided by 2. So that's log 16 of 2 cubed, which is 8, multiplied by 8 squared, divided by 2. This is going to be log base 16. 2 cancels into the 8 4 times. 4 times 4 is 16, carry over 1. 4 times 6 is 24, plus 1 is 25. 256 is actually 16 squared in disguise. Log 16 of 16 is 1, so this evaluates to 2. So this is going to be log 20 plus log 2 plus log 125 to the exponent 1 over 3. This essentially means the cube root of 125, which is 5. So again, remember. So because of that, this becomes log 20 plus log 2 plus log 5, which becomes log 20 times 2 times 5. 20 times 2 is 40, 40 times 5 is 200. This is the same as log base 7 of C plus log base 7 of D. This is the same as log base 3 of M minus log base 3 of N. Which is equal to log of U plus 3 log V. So this is log of A plus log of B to the half minus log of C squared. This is going to simplify, if you can call that simplified, to log A plus 1/2 log B minus 2 log C. This is the same as log 10 over log 2. there's also another way to interpret that. That could be the same as log base 2 of 2 times 5, which is the same as log base 2 plus log base 2 of 5. That's 1 plus log base 2 of 5. And then the last one, that's the same as log base 5 of 25 times 2. So log base 5 of 5 squared plus log base 5 of 2. This is the same as 2 log base 5 of 5 plus log base 5 of 2. This is the same as 1, so this becomes 2 plus log base 5 of 2. So this is going to be the same as this is the same as 4 over 2. This is the same as 1 over 2. So this becomes log of x to the 3 over 2. Which is the same as 3 over 2 log x. So we got the addition of two logs, so that's the same as log of the product of this and that. So if you look at it, we've got square root of m now the square root of m times the square root of m to the 7 gives us the square root of m to the 8 . Now the square root of m to the 8, think about it like this. The square root of m is 1 over 2. And then you've got the 8. That gives you a result of m to the 4. And then on the bottom you've got m to the 3. And when they cancel out, you're going to be left with m. Now keep in mind you're dividing out x in the first part, so there was a restriction there. X has to be greater than 0. And in this situation it's the same restriction. M has to be greater than 0. You don't need to specify that it can't be 0 because that's implied by greater than 0. the square root of k times the square root of k to the 3 will give us the square root of k to the 4, which would wind up giving us k squared, k to the 2 over 3. So if you think about it, 2 over 1 plus 2 over 3 is the same as 6 over 3 plus 2 over 3, which is going to give us 8 over 3. So this is log of k to the 8 over 3, which is equal to 8 over 3 log k. Because we've got the square root and odd roots, we also have to keep in mind that k must be greater than 0. It's going to give us log w squared plus log w3 over 2 plus log w. And when I multiply all of that out, that's going to be log so you've got 2 over 1 plus 3 over 2 plus 1, or 2 over 2. 5 over 2, this is the same as 4 over 2. Which is the same as 9 over 2 log w. W must be greater than 0. Alright, question 10. This is going to be the same as log of x squared minus 4 over x minus 2. But that's a difference of squares on the top, so that's the same as saying log x minus 2 x plus 2 over x minus 2. These two cancel as long as x is not equal to 2. And so that's going to simplify to log of x plus 2. And since this has to be positive, x has to be greater than negative 2. Negative 2 would give it 0. Negative 2 plus 2 is 0, but it can't be 0. It has to be greater than 0. So that's why you've got that restriction. Alright, so we go to B. This is equal to log of the top expression, and this one that's being subtracted goes on the bottom. So you can see right away that x cannot be negative 3. We do a little factoring on the top. X plus 3, x plus 4, That leaves us with log of x plus 4. And our only restriction is x must be greater than negative 4. So we can write that as log x squared minus x minus 6 over 2x minus 6. I'm going to factor the top, x minus 3, x plus 2, and on the bottom 2x minus 3. So I've got a couple of restrictions. X cannot be 3. Now I can do that. So that's going to give me log of x plus 2 over 2. So we're going to factor the top, factor the bottom. X cannot be plus or minus 3. So a couple of things. First of all, the argument for log must always be greater than 0. Now there's two ways to look at that. X squared minus 4 is basically this graph, and x minus 2 is basically this graph. So this one's positive when x is greater than 2. This one's positive when x is less than negative 2, or when x is greater than 2. So the only region that's in common is x greater than 2. Okay, so now we go to solve the actual question. That's going to be log of x squared minus 4 over x minus 2. Notice we don't have to worry about x being 2, because if x is greater than 2, it excludes 2. So this gives us log of x minus 2, x plus 2 over x minus 2. Now since x is not 2, since it's greater than 2, these two cancel out, and your final result is log of x plus 2. The only restriction, x must be greater than 2. I'll try and explain that again for part B so that you can see how that process works out. So let's say we have log of x squared plus 7x plus 12 minus log of x plus 3. This is the same as log of x plus 3, x plus 4 divided by x plus 3. Now let's talk about restrictions. X plus 3 cannot be 0, so x cannot equal negative 3. X plus 3 must be positive, so let's look at that graph there. X plus 3 looks like this. That's 3, that's minus 3. So x is going to be positive. X plus 3 is going to be positive whenever x is greater than negative 3. So far we've got x greater than negative 3, which satisfies this. And then we also have x plus 4. X plus 4 is positive whenever x is greater than negative 4. Well, if x is greater than negative 3, it's also greater than negative 4. So, since x is not negative 3 because it's greater than that, these two can cancel, leaving us with log of x plus 4, and our restriction is x must be greater than negative 3. So look at this next question, log of x squared minus x minus 6 minus log of 2x minus 6. Now this is the same as log of x minus 3 x plus 2 minus log of 2x minus 3. And what that's going to give us is log of x plus 3, x plus 2, First, before we do that, let's look at our domain restrictions. X minus 3 must be positive. In order for that to be positive, that's minus 3. That's 3. X has to be greater than 3. For this one, x plus 2, that looks like this. And x plus 2 is positive whenever x is greater than negative 2. Well, if it's greater than 3, It's automatically greater than -2, so there's our restriction. Now, this becomes log brackets x minus 3, x plus 2 over 2x minus 3. Since x is greater than 3, this is not 0. That's going to give us log of x plus 2 over 2. And our restriction is x is greater than 3. Alright, this is the same as log of x plus 3, x plus 4, minus log of x squared minus 9. That's the same as log of x plus 3, x plus 4, divided by x minus 3, x plus 3. So that's just x squared minus 9 is just x minus 3, x plus 3. Alright, now we have to do some domain analysis. Alright, when is x plus 3 going to be positive? That's going to be positive when x is greater than -3. When is x minus 3 going to be positive? That's going to be positive when x is greater than 3. When is x plus 4 going to be positive? When x is greater than -4. So the ones that have all three in common is when x is greater than 3. If x is greater than 3, this will not be 0. So they can cancel out. And so that's going to give us log of x plus 4 over x minus 3. And our restriction is x must be greater than